Hey, Chem 1110, it's Dr. Patton. We're getting close to the end of the semester, and today our experiment is going to involve titration. Some of you may have done these in maybe a high school lab, but we'll go through in this first brief intro, and then we're actually going to do the experiment. So let's begin by discussing what a titration is. A titration is the slow addition. So we're slowly going to add a solution, the slow addition of one solution. And we're going to add this solution. We're going to call it our titrant. And we're going to add it. And we're going to add this to another solution. Until the reaction that we're focusing on is complete. Put that back. Okay, so that's the general idea of what a titration is. It's the slow addition of one solution that we're going to call our titrant to another solution that's going to be in a flask. It's our analyte, our species of interest, until the reaction is complete. And the type of reaction that we're going to focus on today is an acid-base neutralization reaction. So let's think of an acid-base neutralization reaction that we might be familiar with. If we take a strong acid, HCl, that's hydrochloric acid, and we react it with a strong base, such as sodium hydroxide, we can slowly add one of these, such as the sodium hydroxide, to our strong acid, slow amounts of it, and allow the reaction to occur until it's complete. And this is known as an acid-base neutralization reaction. Once we've added just the right amount of sodium hydroxide to react with all the HCl that's present in that environment, we're going to end up, for an acid-base neutralization reaction, with a salt. And in this case, the salt that we're going to produce is sodium chloride, and that's the sodium anion, cation from our base, and the chloride anion from our acid. Now what's remaining here are hydrogen ions and hydroxide ions, and that's going to produce water. So this is an acid-base neutralization reaction that we have here. And this is the idea of what we're going to be doing today. We're going to be taking an unknown acid, not HCl, an unknown acid, and we're going to slowly add some sodium hydroxide to it. The sodium hydroxide is going to be in a piece of glassware that we call a burette, and we're going to monitor the process as it occurs by using an indicator dye. The indicator dye that we're going to use is called phenolphthalein. Phenolphthalein is going to be clear when we have a solution of just an acid such as HCl. Once the reaction is complete with the sodium hydroxide, we're going to see a color change. That color change is known as the endpoint. That's the physical appearance, the color change that we see in that environment that tells us that our chemical process has reached completion. And we're going to use that information for today's experiment to determine the molar mass of a particular weak acid. And we'll go over a sample calculation involving the titration process. So we're going to go through our demonstration. So there's going to be a second video on that in just a few minutes. Thank you.